Hey everyone, good evening. It's Brian here. Today we'll be going over Leetcode number 3, the longest substring without repeating characters problem. This is a Leetcode Medium problem. It's pretty popular, but I actually haven't personally seen it in an interview. So we'll just be going over the solution in Python 3 today. I don't have any fun anecdotes, and we'll go over what makes a good answer, how we reach our algorithmic complexity, and we'll run it. So without any further ado, let's read the question together. All right, so reading over the problem, we are given a string s and we will find the length of the longest substring without repeating characters. That's a very short problem description, and the input is simply just a string called s. In example 1, we can see that we have ABC, ABC, BB. So our longest substring without repeating characters is ABC, and then once again we have ABC, and BB is repeating so it doesn't count. In example 2, since we have all B's, we're only ever going to push our counter to 1, and then we're just going to keep resetting. And in example 3, we have PWW, KEW. So the longest repeating will actually be WKE, because WKEW would count as repeating. And PW is one part of a substring, and WKE is then the actual longer part, since it's 3, which is longer than 2. And then lastly, in example 4, it's blank, so we're just going to make sure that we're given an output of 0. So that's the easy one. We could either code this out of the way in an interview, or we'll let our solution naturally take care of it. Let's break down this problem a little bit. I see that we're going to have to find the length of something that could be anywhere in a string. We're going to have to break down the string into multiple sections, and each section could have its own, this first index could have as long of a run as the whole string, or in theory, it could be, from the second one all the way to the second to last one, etc. So it could be anywhere in the problem of any length, and we're going to have to check multiple times throughout the array. So this kind of sounds like a little bit of a difficult problem, right? Well, this is similar to some other problems we've looked at before on this channel, in which when you have some form of an array that you're going to have to sweep over several times of varying ranges, that lends itself to something called a sliding window solution. And what this means is the sliding window algorithm is essentially we're going to have a window that could get larger or smaller, and we're kind of just going to sweep it across the whole array, and we'll find our optimum solution through that. Sometimes you need one pass, sometimes you need 2 passes over the whole array. In this case, this problem is not immensely complex, so we'll just try doing one pass with the sliding window algorithm first, and we're probably going to need to initialize something in memory to help us keep track of what we've already seen, because we want to find the length of the longest substring without repeating characters, and that is the key part of this problem. So let's go ahead and think about what can help us there. Well, what data structure would we use if we want to keep track of something we've already seen and easily access it and keep track? In Python, we'll probably just go with the dictionary. They're pretty lightweight. As of Python 3.7, they're also ordered if we care about that, and they're just super convenient to start with. So let's go ahead and do that. Because dictionaries have a faster access time than arrays do, and dictionaries are constant, being O of 1. So it seems like a very good place to start. So we're going to initialize a dictionary that keeps track of seeing characters first, and then I'm going to think about what else does my sliding window algorithm need. Well, we know just from the basic understanding of a sliding window algorithm will need a left and a right, which are both going to be initialized to 0. And the right is eventually going to meet the end of the array's length. So what this means is that we know that we'll have a left and a right, and we're going to initialize those to 0. Likewise, our output in this problem is an integer, and our integer is going to be starting at 0 up to as long as the length of the string. That's our maximum. So we can also initialize the output that we're going to give here, and we'll call that output 0. And all of these are going to get initialized to 0, which we can do a simultaneous assignment in Python by just simply writing our 3 variables, 1 equal sign, and then our 3 returning results. And I think that just looks nice and clean as code to write, especially even if you're on a whiteboard and you have limited space. You can just write this all out on one line rather than taking up the whole whiteboard vertically as you debug your code. All right, so moving on, we have our variables initialized. We can always add more if we need to, but I think we have what we need for now, and instead we can move on to a loop that starts processing our array. I'm going to go with a while loop because we're just sliding it until it's at the end of the string, which we're going to break down into indexes essentially, so it's like a string array. You could also do this with some type of enumerate or a for loop, but I just feel like the while is a little bit easier to conceptualize here. So we have while right is less than length s. Note that we don't have to do length s minus 1 because we're only using the less than, not the less than or equal to symbol. So with that line written, we can now think about what's going to happen in our sliding window. Well, we know that we're going to have to handle if we haven't seen a character before, and we're going to have to handle if we have seen a character. And the have seen a character logic is probably going to be a little bit harder. So let's save that for later, and let's first write our if-else statement. So thinking about this, we're going to say that if something is not in seen, right? We haven't seen it before, then do logic, else it has been seen, and then we're going to do logic. And as we iterate through and as we see or perform logic on things, we're going to need to update this overall. And as we go through the sliding window, we're going to also need to update scene because it's unique per section of the window that we're working with. It's not just going to be completely static throughout the whole process. So let's iterate through. We'll just write right plus equals 1 to advance our array. And let's think about what we're doing here now. Right is going to be the amount of characters that we're indexing towards the end of the array, which is going to be something like incrementing 0 to 1, 1 to 2, etc. And we know that that count is something that we're trying to keep track of with scene also. So we're going to perform a access on scene, and we're going to think about what key we will use to initialize it to be what right currently is. Say that our key exists at some index position. Then we want to access whatever that key is there for our array, and we're going to update that key's value to be whatever number we're currently at, counting places to the right of it. That would be a longest substring. That may be a little bit confusing to word, so I'm going to show you an example here. If we write this out, right could be some number equal to or greater than 0. And then here we are accessing the index position of a string. So say that right is going to be the 0th index. Then we're accessing the character that lives at the 0th index, in this case A. And the counter of right is also 0. So now scene gets the key of A with the value of 0. And our dictionary would end up looking like we have A with a 0 there, and so on and so forth. And that will build out as we go through our entire while loop, and that is going to help us build out the sliding window problem. Otherwise, we would just have an array that never gets its key value pairs updated. So the contents for your value wouldn't matter to another section in the sliding window. It would only matter to the current frame that you're on. And this is an advanced algorithm, so don't worry if that is a little bit shaky right now to you. So deleting that comment for cleanliness and moving on. I'm pretty happy with what we have here in terms of advancing the algorithm. And let's consider what we're returning. Well, we already wrote that our return statement is our output here, which is 0. So we're going to return output at the very end once the algorithm has naturally terminated. I don't think any other termination cases need to occur because we don't have a need to terminate early in this problem, as we have to look at the whole array anyway. So we're going to leave this as our only return statement, and now we're going to start thinking about the logic here on line 7. All right, now this is where it starts to get a little bit fun. And by fun, I mean possibly stressful. Over here, I know I left that as an underscore, but we're going to do something similar to what we had here, in which we are going to grab the character as our key that lives in whatever part of our array that we're accessing right now. So we're going to say that essentially right starts at 0, so we're at index position 0, and we're going to access the 0th element of S, which in example 1 is A, and in example 2 is this first B. So with that said, now we're going to have to do some logic there. Well, if we're going to update our output, we want to return something larger than 0, right? That's the core thing that we're trying to get towards with this problem. So we need to think about this. Output could either be whatever we're currently at in that output counter, or it could be something bigger. Say that we are advancing our window and we've done some new math on realizing that ABC is longer than our current output of AB, and we want to update that 2 to a 3, for example. Then we need to figure out, how do we update that? Well, a common trope in Python is you use max with the current variable that you would be outputting, along with a new set of math. So I'm going to write that there is some new math. Now the current thing we would have to think about, and this is rough during a live interview, is what is this math? We know that right is going to be the amount of characters from the point that we started reading towards the right of the string. So say that we're at 0 and we're reading now 1, 2, 3 over from A. Right would be keeping track of that rightmost character that we've looked at, and left would be keeping track of the index position of where we started, which is A being 0. Likewise, don't forget that this is going to start from a 0 index, so we're going to have to pad it with a 1 because we do count that one character. For example, ABC would be index 0 going to index position 2, but our output is actually 3. So if you think about that math a little bit backwards, we're at index position 2 and we're subtracting an index position of 0, but that would return us 2, so we just need to add an extra number, and we'll always have to add that extra number. So that concept put into code is starting to make a little more sense. We can think of it as right is our rightmost thing that we've iterated through, and left is the index position that we started at in our current frame of the window. So in this case, for example 1, our right is at index 2, our A is at index 0, and we're going to have to add a 1 to make us get a nice 3. And if you're not quite following beyond this example, take a moment to pause the video, go through example 1 and 2, and see how this statement does hold true even beyond this first ABC. For the sake of time though, I'll skip that for now and move on to the else case, which is a little bit more complex. So now moving forward to else, this is the case that we have seen something before. So now we have to handle some complexity here. If we've seen it before, but the value for the right side is less than left, that means our right is before the left, and that logic doesn't quite make sense in what we're updating. So instead, what we want to do there is we just want to reperform the operations we've done here, because we're just treating it like that then. So we can say that if we've seen something and the value of the character that we're looking at has a rightmost value less than what our current left index of the sliding window is, and you're going to have to visualize this a little bit, then we're just going to reperform what we've done because we're essentially doing this case again. Because we have seen it, but its right index has not progressed beyond our left, so the window doesn't quite hold. Now in our else case, we have seen something before, and the other side, the right side, has progressed further than the left. Therefore, we can start doing some update to the left side of the window. And this is where the window algorithm all starts to come together, because right now we've just been sliding the right side, right? We haven't updated left at all, so it might have been a little bit confusing there. But now we're going to update the left side of the algorithm to start catching up with the right side. So we have a window that not just expands towards the right, but can also start sliding with it towards the right too. So we know that we're going to perform some assignment to left, and we're going to do that based off of what we have currently seen. So we have seen on our string, and we're going to again access the key of the rightmost character. And then we're going to increment it by 1 because we're just sliding that left window over by 1 if we have seen something and the right cursor has progressed further than the left. We just need to increment that left window then. Otherwise, if we haven't yet done anything with this window, this current line 12 isn't going to even be hit for a while because remember, this if statement first has to be hit, and that's going to have us start updating our output anyway for our algorithm. So now with all of this written, we can take a little bit of a step back and look at the problem. We have right being updated, we have left being updated, we have our output being updated, and our while loop will not infinitely loop because we are forcibly updating right by 1 every time we finish all of our logic here. And we have a else case that will update left once the right conditions are hit. So looking at all of that, we can give our code a run because we know that we don't have anything that will immediately terminate the problem. So let's go ahead and try running our code. And we see that our code has been accepted. We have our correct output and expected. And now I'm just going to go ahead and submit the code to verify that it passes all of the test cases. And looking at that, it does pass. Our runtime is pretty good, 81%. Our memory usage is also pretty good, less than 80%. And looking at a glance, explaining the algorithmic complexity of this problem during an interview won't be too bad for you. We just have one while loop going over the entire string. So that will be linear runtime, thus O of n. We have a dictionary, and that dictionary can get as large as the entire string, assuming every string is a unique character. So that will also grow with a memory complexity of O of n. Now we may have more accesses than that because we've accessed the dictionary quite a bit. But as far as it's concerned, the algorithmic runtime and memory space complexity of this problem is O of n, or linear runtime for both. All right, that was a Leetcode Medium problem that's actually quite difficult in less than 20 minutes. So I hope this tutorial was helpful for you, and good luck in your interviews out there. And remember to pick Python if you want something to be as convenient as this. And if you have made it this far and haven't already, please consider subscribing to the channel and giving the video a thumbs up icon below. It would mean a lot to me, and it would really help out my channel and videos improve. And I'll just keep making these so I can cover every Leetcode problem there is out there. Thank you again so much for watching.